Thanks, Keith, and thanks to everybody for joining today. We're going to spend the next 45 minutes to an hour talking about de-identification in the clinical trials industry, and really some of the ability we have now to reduce the cost and the effort associated with performing this task. From an agenda perspective, there are several things we'll be covering, and the first one is the increasing pressure to de-identify clinical trial data. Where is this pressure coming from? How are we seeing it as we talk to customers, and probably how you're seeing it as well. Two is the second point of the agenda is some of the existing approaches that are in place today and why it's really time to look at a different approach. There'll be a demonstration where you can actually see the software that DWise has developed in action, so you can get a feel for how we're tackling this problem from an application perspective. And then certainly at the end, there'll be time for questions, and I'll do my best to provide answers live during the session. So the idea of de-identification actually maybe started a long time ago in a galaxy far, far away. And hopefully folks are here today to learn a little bit more about how DWise and the industry is tackling de-identification, and not here just for the very cool, very interesting BB-8 droid that was part of the incentive to participate today. We've got a lot of good content to cover, and specifically what we're going to do here today is talk about where clinical trial data has value beyond its original intended purpose. So certainly as part of a clinical trial, the data is collected to prove the hypothesis and the protocol, to demonstrate the safety of the research program. But there are a lot of other capabilities associated with how that data can be used. And the first is around sharing data for internal purposes. So a number of the customers that we've been talking to have helped articulate where data might be useful and where it might be used. Certainly from a planning and exploration perspective, after a trial has been completed, the available knowledge associated with that trial gets aggregated in some fashion. And it's very useful at that point to share it or to apply it from an exploration perspective. What does the next trial look like? How many more trials do we need? What do we need to show that might be different? Organizations are also very interested from a marketing perspective in terms of how that data might help them target particular audiences and identify different channels to increase the sales revenue associated with their approved marketed products. And one of the things that was a little surprising, which actually makes a lot of sense, is as companies engaged in clinical research look to test new software products, not necessarily our software products, but any new industry software product, they want to test that new product on real-world clinical trial data. And a number of companies really are taking a very conservative approach here, in that the data that's been collected as part of a clinical trial really has to be used just for that clinical trial, and they struggle with the means to test that new software product on real-world clinical data unless they de-identify the clinical trial data with which they're working. So that's kind of an important consideration as well. There's a lot of concern that anything beyond the use of the data that's described in the informed consent really has to be done in such a way that the data is disassociated from the actual patient. And the best means of accomplishing that is by de-identifying the data in a correct and proper way. There are also a number of external data sharing initiatives where the clinical trial data has a lot of use. For folks that are familiar with Project DataSphere, that's a project that's at this point maybe 3 or 4 years old, where a number of pharmaceutical manufacturers are pooling selected oncology data to improve the overall understanding of oncology as a comprehensive illness. Obviously, it's a very complicated disease to identify a treatment for. More recently than that, a number of pharmaceutical companies, depending on how you count them, 12 to 20 really, are engaged in some level of a clinical trial data transparency initiative, where they are posting research data through a controlled portal based on researchers' requests. So a researcher says, I'd like to have access to clinical trial data, the pharmaceutical company is posting it, and prior to that, the data is de-identified to reduce the risk that the patient will be associated with this more public data. And the last point around sharing is really around publication support. And in recent days, it's really changed more from a publication support scenario to a publication enablement scenario. A number of journals, for example, the British Medical Journal, have said we will only publish scientific articles if the researcher agrees to provide data if it is requested by a third party. So really, if these researchers want to get their information published, they've got to be in a position to share that information. They don't necessarily have to provide it right away. Each journal has their own policy around this, but they need to be in a position to make that data available and to do so ultimately in a way that is efficient and cost reduced. Because for the most part, that work tends to be secondary or beyond that in terms of their actual research program. The thing to keep in mind throughout any of these secondary use initiatives is that the research organizations, they really need to balance the desire to use that data with all of the legal and ethical expectations that that are part of the industry. It's not as simple as saying we want to make that data available, we're going to make it available. It's got to be done in a controlled and proper way. I know that we've gone through a couple of polls. I'd like to try one more now. Bear with me just a second. And just try a sense of whether or not, for the folks on the phone or on the webinar, how many folks are actually seeing de-identification used within their organization today. So the poll is open for a couple of minutes, not a couple of minutes, a few seconds. We'll take a tally here in just a second, and then just see who in the audience is really actively participating in de-identification. Let's move on and actually see what we have. So there are a number of participants, more than half are actually doing de-identification today. Another, about 25% are aware that it's going on in their organization, and a handful are not really sure, which is great. It's a chance to kind of share experiences, learn a little bit more about how de-identification might impact your organization, and perhaps identify longer term how to reduce the expense at your organization. When we talk about secondary use, there are a number of business drivers that are in place. What is driving the need to share this information? And really the primary driver at the outset is accelerating the availability of these data assets. So the clinical trials data is valuable. I think if you talk to patients that are participating in clinical trials, they want to see their data used more broadly. A lot of them really want to know the outcomes of their trials. There's a lot of interest in making, in general, the data available from a personal perspective, from a manufacturing perspective, from an industry and a science perspective. But that has to be done in a controlled way. And some of these controls include protecting patient privacy. How can you help ensure that the patient's personal information doesn't actually get linked back to them individually? Honoring the informed consent that all patients have signed. We've talked a little bit about that already. The notion is that when a patient consents to a trial, historically it's been just for a very narrow use of their research data. And if the data is going to be used for anything else, their data needs to be disassociated from their actual personhood. And the other point is assessing and managing risk of sharing this information for secondary use. I think it's fair to say that there's always a risk that the patient information can be re-identified. That risk will never be dropped to zero because, as we know in the world today, there are always malicious people who have, whoever has sufficient time, money, and energy and resources can identify whether it's clinical trial data or financial information. All of that can be at risk. The goal is to assess what the real risk is and ultimately to manage that risk. So I want to spend just a minute here talking about what the risk is around re-identification. And this is not going to be a comprehensive study of re-identification risk. There are a number of publications that are available, and I can certainly spend time on this offline. But re-identification risk of patient data is it's a function of actually many factors. I want to highlight 3 here, and that's the intended downstream data use. What's this data going to be used for? In terms of so you know what's being shared. You don't necessarily have to share all of the data associated with the clinical trial. It can be much narrower than that. depending upon the downstream data user's interest. What are the terms of use? What is the downstream data user permitted to do with that information? Most of the time when we talk about data sharing initiatives, that downstream data user is signing an agreement that says what they will do. It's not just a free-for-all in terms of we're going to make data available and the downstream user can do whatever they want with it. And the third point here I want to touch on is accessibility. How will that information be made available? There's a big difference between using data internally at a pharmaceutical company where the employees of the company have a well-documented obligation to protect the information that's available to them, and posting it on a web portal where anybody from the public can access and download it. That's a very different risk profile in terms of how that data will be used. And it's probably worth mentioning what Transcelerate has said as part of their de-identification model approach. So Transcelerate, for anybody that's not familiar with them, is a consortium of leading pharmaceutical companies that are trying to tackle industry-wide problems. And one of the topics that they've addressed is clinical trial data transparency and data de-identification. And in the spring of 2015, I think it was May, they published a document that described the model approach that they recommend. And it's not a requirement, it's not a regulation, it's a guideline of how this consortium of leading companies thinks de-identification should be addressed. And one of the things they say in that publication, as they talk about risk, is that depending upon the type of information that's being shared and the access model that's being used, that manufacturers, data providers, manufacturers may decide that a detailed statistical assessment of risk re-identification, which is an approach that can be taken, may not be necessary in most cases. They don't say all cases. There are certainly cases where risk requires a more detailed study. But what they've come out and said is that in most cases it may not be necessary. So I don't want to discount the fact that risk is part of a discussion, but there are different ways of approach from a business process perspective and from understanding downstream data use, terms of use, accessibility, and so forth that factor into that discussion. When we talk about data de-identification, one thing to keep in mind is that a lot of folks that work in the clinical trials industry already think clinical trial data is de-identified. We don't collect patient names. We don't collect kind of the traditional identifying information that you would typically see in HIPAA regulations. So there's no address or phone numbers or social security numbers, that type of information. However, there is a lot of other information that is collected that can be used to potentially re-identify patients. And that's the information we have to manage, and that's the information we have to de-identify. That data some of those data points or data types are listed here, but it includes things like dates and investigator names and outlier values, free text fields and comments. All of that can have an impact on the ability of somebody to re-identify a patient. And just because we don't have name and address and phone number doesn't mean that the data is already de-identified. There is certainly work to be done, and that work has been going on in the industry for some time. And there's some challenges to getting that work done. So historically, when clinical trial data has needed to be de-identified, it's been a kind of a low volume, low visibility process. The requests have been infrequent. When the work needs to get done, it's usually done using kind of minimally maintained tools because the tools are not used all the time. They fall into a kind of a sense of lack of upkeep over time. The folks that are charged with doing the work tend to be drop-in resources. It's not a full-time job for anybody. So it's whoever is available, has some knowledge of the study, maybe has some knowledge of the tools. But project by project, it's not necessarily the same people that are familiar with either the process of de-identification or the tools that are available. It's not always the highest priority work. Most folks that work in the industry are primarily focused on delivering data to move through the marketing application process, proving the outcomes of clinical trials, assembling study reports, preparing a submission, and so forth. So when the work does require to be done, it doesn't necessarily come to the top of the list. And for all these reasons, there's very little automation around the process. It tends to be very manual, very hand-operated types of work where folks are editing code and submitting projects on a data table by data table basis. But the growing interest in making this data available for secondary use is really starting to stress these processes in place. Whether you're outsourcing the work or whether you're trying to identify teams within your organization to perform the work, there's a lot of influence and pressure to do things faster and at greater scale. Some of that's related to EMA Policy 70. Some of it is related to dependence on what are already scarce SAS programming resources in most organizations. And in general, an inability to scale the processing, whether it is due to technology or staff or time in the day. So all of that really creating a challenge in the delivery of clinical trial or de-identified clinical trial data. And behind that is really the sense that public sensitivity to privacy really has never been higher. So as folks are doing the work, there is a great sense that it needs to be done well, because not doing it well has an implication for the entire organization. As we see periodically, whether it's the government having information stolen from them or individual organizations, folks are very concerned that privacy is a top-of-mind issue for consumers and citizens of the world. So I want to spend a minute or two talking about how DWISE has been working in this space. So we're like a number of other organizations, really spending a fair bit of time trying to understand the landscape of de-identification from a business perspective and from a technical perspective. Part of what we've done is we've been engaged with the FUSE working group that has defined a set of de-identification methodologies and rules. For anybody not familiar with FUSE, that's the Pharmaceutical Users of Software Exchange. It's another consortium of industry users, technical users that solve or attempt to solve a series of industry-wide, usually data-driven problems. And that group published its own findings and set of rules and recommendations also in the spring of 2015. DWISE has been engaged with that group as part of that committee. We've been speaking and talking to customers and providing thought leadership at a number of industry events around CDISC and FUSE and SCDM, the Society of Clinical Data Management, as well as some SAS events, trying to get a better understanding of what issues our colleagues are struggling with and how best to solve them. And importantly, we developed and implemented a software solution with AstraZeneca. That's been probably a year-long process now, where we spent a great deal of time polishing our own system requirements, learning from AstraZeneca what their expectations are, and getting some real-life experience around how the application works on real clinical trial data. I'm very happy that project has moved forward and that DWISE's software solution, as you can read here, is helping AstraZeneca achieve their goals in a way that continues to safeguard the quality of the data. I've been doing this now pretty solidly, and we're really excited to be able to continue the process as we improve the application that's available and as we continue to talk to more and more folks in industry. And that really leads me to where we are today, and that's with the DWISE de-identification solution. It's called Blur, and Blur is really the industry-leading solution for delivering de-identified clinical trial data and protecting patient privacy. There are not many really commercial solutions available in general around de-identification, and our application is specifically developed to deal with the nuances of clinical trials data, and we'll talk a little bit about that in just a few minutes. I want to spend a couple of minutes here talking about the value of Blur, what it really is bringing to the table. We've done some internal analysis around the effort level associated with de-identifying data between using the Blur application and doing it more traditionally by hand with SAS scripts or SAS macros. And for data that's been standardized, so typically a more modern CDISC type of data structure, we see a 70% reduction in the effort associated with using Blur instead of using it through a hand or a manual SAS-based approach. For data that might be older and isn't standardized very well, the efficiencies are actually larger because you're not having to kind of hand tool each SAS line to match the data you have available. The application provides an interface to really streamline that information or streamline that process where we're not having to work through every line of code to make sure it works correctly. So it's a pretty significant reduction from that perspective. And for companies that have been outsourcing, there's a recognition that that outsourcing, typically an expensive proposition, can be reduced through the application, reducing the effort by 70 or 90%. The work can actually be done in-house or potentially outsourcing provider could work on the application and see a streamlined effort for that as well. From an efficiency perspective, the Blue application understands CDISC and SAS and other types of data that you typically see within the pharmaceutical industry, whether it's vertical data like lab files or vital signs, or more horizontal data like demographics and adverse events. That the application understands how to manage that information and to de-identify it appropriately. We are supporting the FUSE rules, the Transcelerate rules, and other emerging rules in the industry as organizations get a little further into the business process associated with clinical trial data de-identification. That includes things like how you manage the key mappings that map the original user IDs, the original subject IDs to the de-identified subject IDs, and how that information should be either preserved or destroyed over time. There are integrated workflows built into the process that are designed to mirror how the industry typically works around the data transformation process, where somebody does the work, somebody else reviews the work, and there's a cycle of approval that has to address. And encompassing the entire application are audit trails and other controls that really document the activity associated with the de-identification of clinical trial data. And from an IT perspective, the goal here is, again, to reduce costs so that internally within an organization, there's no significant effort around developing a new application, develop SAS scripts, or maintaining them over time, especially as the work tends to be has been kind of low volume, low priority. And the expectation is that a consumer off-the-shelf application will help enable some industry alignment. While I've talked FUSE and Accelerate, those sets of rules have some alignment, but there are some differences. A dozen or so companies have published their corporate-specific anonymization or de-identification rules. Those have some similarities and those have some differences. By working in a single application, the expectation is that we can start bringing some of these differences together and get more of an industry approach to how we're going to de-identify data. And that becomes actually fairly important as pharmaceutical companies are posting their data through or sharing their data through whatever mechanism makes the most sense, especially when that data is coming from multiple organizations. It really needs to be de-identified the same way so that it's got utility to the user. From a capability perspective, the Blur application is designed to work without a coding interface. There's no place to write SAS code. In a lot of ways, it means it's easier to find resources that can work on de-identification projects. Certainly, you need to be knowledgeable about clinical trials. You need to be knowledgeable about the de-identification process, but you don't necessarily have to be a syntax expert in SAS or SQL or R or whatever language you might be using. By working in the application, there is the concept of a reduced risk and increased compliance in terms of having constraints around how the information can move through the system, so it's more difficult to introduce mistakes into the process. We've talked about the costs being decreased, and overall that contributes to a lower total cost of de-identification in terms of all of the efforts around development, maintenance, services. All those pieces result in a lower total cost of ownership. From a workflow perspective, we've talked about this a little bit. We've got automated work transitions within the application so that as a de-identifier completes their work, they can pass it along to a reviewer within the application. That reviewer can ultimately sign off on it in the application or reject it if there's a problem. All that's managed internally, and ultimately what comes out of that is a sign-off that says the data is ready to be released out of the system because everybody agrees that it's complete. There's documentation that's automatically generated that shows every field and the rules that were applied to that field, as well as a record of where the data came from and how it was produced and so forth. All that is automated within the system. Importantly, only de-identified information can be extracted out of the system. It's not a case of you can think you're done and you're really not. The only time data comes out of the system is after it's been de-identified and signed off by all the necessary parties. And I mentioned before there's an audit trail that tracks all the activities associated with the system. The other thing I want to point out here is there's certainly the recognition that many clinical trials are similar. So Blur provides the ability to create a template that can be applied to multiple projects. So for example, you might create a CDISC SDTM template Or you might create a different template for different therapeutic areas or different phases of the trial, whatever makes the most sense based upon your business situation. And the way that works is as you complete the project within the Blur application, that completed project becomes potentially a new template for someone else down the road. There's no requirement that you have to use templates, but it certainly makes a lot of sense to continue to improve and evolve your work over time so that when the next project comes along, it gets automatically scored against your library of templates. And when you see the scores, you can make an intelligent choice around which template would be a good starting point for my project that I'm working on right now. And the thing to keep in mind as part of this is that even if your score is 100%, there's 100% fit between your current project and the last project that was templated, there's still work to be done. There's no magic bullet in terms of being able to say, oh, it worked before, I guarantee it's going to work this time. There's some due diligence that has to be performed, but the vast majority of the work will have been completed. And if you're working with either CDISC or you've got internal standards or historic standards, whatever you've got in place, all of those types of standards can be templated as well. And that's something that customers control. It's not something where the customer has to come back to DWise and say, we need a new template for the next version of CDISC. We can certainly provide that, don't get me wrong, but it's not something where there's an obligation to come back to DWise all the time and say, we need a new template. Please take care of that for us. All of that leads to the goal of achieving the goal of a high-quality, fast delivery, and low-cost method of de-identifying clinical trials data. We've touched on some of these things already, but the goal here is around we built a product for clinical trials, so we understand Transcelerate, we understand Fuse, we understand the way that data is structured. When we've worked with customers, we've not seen the ability to or the need to manipulate the data prior to loading into the application. We take the data as it exists, and the interface and the workings of the application are designed to take that data and apply rules in such a way that there's not the need to externally manipulate the data to restructure it. And then we're providing native support for the types of data we typically see in clinical trials. SAS data sets, SAS transport files, CSV files, if those are relevant, those are obviously less common, and the ability to produce the results in those same structures as well. So if you're going to de-identify data and make it available to an R program, or maybe you don't want to create SAS data sets, you can create a CSV file or some other type of file. And with that, I'm going to pause for a minute and kind of reset myself and then jump into a live demonstration. I want to encourage folks, if they have questions, post them in the go to webinar control panel. I've gotten one question so that someone can hear me. Hopefully that's been taken care of. I do apologize for that. But if you just bear with me. So I'm running Blur through a browser. I happen to be using Chrome, but a variety of different modern browsers are supported. There's nothing to install locally. And I'm going to log in with my credentials. There's nothing more exciting than trying to type in authentication credentials in front of a live audience. So what you're seeing here in the demonstration is I've got a series of projects, and these are projects, some of which are completed, some of which are in progress, some of which are new. And what I'm going to do is I'm going to select a new project to work on. Just to help you navigate a little bit, there's an activity log that kind of shows you what's going on from my perspective as I'm doing the work. That's information that's contributing to the audit trail. You can see if there are active jobs being run as I'm de-identifying things. The jobs will appear. They tend to run very quickly, so you might see things pop up and disappear. Larger data sets take a little bit longer to run, so it's an indicator of what's running and what's not. So I'm going to go into project 404 in this case. And the first thing you'll note is that I don't have any tables to work from. I'm going to really start from scratch here. And I've got some actions I can perform, but I'm going to do those after I add some tables. So I'm going to choose some files to upload. There are actually different mechanisms for loading data into the system. I'm just going to choose some files through the browser interface here. And I'm going to pick 3 files, and I'll pick this PDF file as well. So as those are loading in the system, I do want to mention that this PDF file might be a good example of a reference document, in this case a sample protocol. It could be an annotated CRF. It could be a study report. The thing to keep in mind, and the important thing to keep in mind here, is that we're not de-identifying documents at all in the application. The documents are references. They may be useful, but at the end of the project, when you're exporting content, don't think that if you've uploaded a study report, that study report will have any redacted information. The study report is going to look exactly the way it did when you started the project. The tables will have changed, but we're not doing anything with the documents and providing them references. One of the things I want to do at this point is I've loaded my data. You can see 4 tables here. Those are the 4 that I selected. What I want to do is see if I can assign a template. I talked about templates earlier. So I'm going to take those 4 tables, and those are actually already been scored against a series of other templates I created. Not surprisingly, at least from my perspective, it matches 100% to the CDISC-STTM template. That's because the data that I've loaded I know is CDISC-STTM data. And if I want to be smart about this, that's the template I'm going to pick. If for some reason I wanted to pick another template, that's fine. Maybe the scores are similar between 2 templates, and based on my knowledge, I can make a different decision. But in this case, I'm going to jumpstart my work from the demonstration here by selecting the best matching project. You can see there's some success information that the template was applied, and you're starting to see some changes to the information here related to the tables that I've loaded. If we look at the demographics table, what I'm going to see here is a preview. This is a representation of some of the unique values associated with this table. So if you look at the if you look at the panel here, what I want to convey here is that this view doesn't represent each row doesn't represent a patient's worth of data. It's more, think of this as columns. So each column has is a representation of the unique data associated with it. So I've got subject identifiers. If I want to maybe switch to variable names, the act arm variable, age units, country. Like I said, you can switch between labels and variable names if you'd like. But this view just shows kind of the unique values. We'll look at the actual data itself in a minute. But this preview lets you see how rules can be applied and what the impact is without actually running it on the entire set of data. If you imagine, laboratory data set, that may take a long time to de-identify, but you can apply the rules very quickly to get a preview of what that's going to look like, and then run it for real a little bit later in the project. The things here I'd like to point out is that a number of de-identification rules have already been applied. I selected a template. It was a good fit for what I was working on, for the project I'm working on, and based on that, the rules are already in place. So the key variable has already been applied or selected. That key variable represents how the tables are joined together. If you think about a merge operation in SAS, and that's by a unique subject identifier. There are some other terms that we want to, or other variables that we want to de-identify consistently between tables. So these act arm value and act arm code columns appear in more than one table, and I want to make sure I de-identify those the same way, so that's a scramble method has been applied. And then age has a numeric outlier that's been applied. If we scroll a little bit to the right, we'll see that I've got a number of date fields, and those have a subject date offset field. So a lot of rules have already been applied. And there are, if you imagine starting from a blank screen, we would start completing this, column by column and deciding what needs to happen. And to do that, what we would do is we would first check out the tables. So you can have multiple people working in a project at the same time. You don't want them working on data sets at the same time, the same data set at the same time. And these columns are actually being set elsewhere because they apply to multiple tables. And the columns on the right, age units, and so forth, are you can set the identification rules for that on a table-by-table basis. So certainly from here, from an age perspective, one of the things I can do is say, really what I want to do is I want to apply a banding rule. So there's a recognition in the industry that age is a little bit of a special variable in terms of how it needs to be treated. Various publications talk about how you can't show any ages greater than 89 years old. So that's certainly one way of approaching it. In fact, that's the rule that's in place right now. It's an outlier rule. In this case, the age is great. I just typed in 75 just for demonstration purposes, and that rule is applied as part of the template. But I can change that here, and maybe I want to apply a band. A band will say that I'm going to categorize age into a series of groups. And the group I'm going to pick here, and these can be longer names, so they're a little more descriptive, is that anybody whose age is between 20 and 80 will have their ages categorized in bands of 10. So I'm going to apply that rule just as an example. And what you'll see here in just a moment is the screen will update with the different bands that are in place. So these ages represent or values that are more than 80. These ages represent values that are between 70 and 79 and so forth. That's just an example of a different type of numeric rule. And that numeric rule, although we're talking about bands, could just as easily be applied to any numeric variable in the study. While I'm here, maybe what I want to do is apply a statistical outlier rule. I don't know if that's as relevant here for age as it might be for other fields, but the goal would be to say if you're looking at height, maybe you want to de-identify patients by height because very tall patients might be more readily re-identified because they're somewhat of an anomaly. So what I want to do is I just want to say anybody that's more than 1.5 standard deviations away, any value that's more than 1.5 standard deviations away, I'm going to remove or redact that information. So I'm going to change the label here. And because I'm changing the value, I need to make sure that the column is long enough or wide to do. So it's a different approach to dealing with age, and like I said, dealing with any other any type of information. See if I made a good choice here. So as I get down a little bit further into some of the unique values, so this value was more than 1.5 standard deviations below the mean. This value is more than 1.5 standard deviations above the mean, and so forth. A lot of different ways to de-identify data. The important point here is that I'm not going to the code. I'm not having to change anything. I've got a fast approach to very easily and very readily de-identify the fields that need to be de-identified. One of the other ways that we're approaching providing great efficiency around the process of de-identification is that you apply date rules across the entire set of information. So dates are a quasi-identifying field within the clinical trial. Their dates are collected in many, many places. So what the application does is on the beginning of the project, as the data is loaded, all of the date fields are identified by reviewing each value, and those fields that are identified as dates are treated a little bit differently. So one of the things you can do after the data has been loaded is you can say, across the entire research study, what I want to do is apply a single rule to all the dates. In this case, I'm going to say I'm going to change all the dates to a year. Now that may not be a common approach. Date to year is typically something you might just see for date of birth or date of death, but just from an example perspective, I want to show what that can look like. So it's going to churn through all of the data here. And if I scroll out to the right, this used to say subject date offset. These are all changed to date to year. You can see the values here have all been changed as well. Similarly, I can use a study date calculation. There are lots of different ways to get to the same point. I'm going to leave this here for now just as a point of reference. The other thing that you might want to do from this perspective, you've got this concept of collections of common information or similar information. We call them row sets here. And row sets let you do two very special things. The first is we can delete patients by a row set, which is like a where clause or a common set of information. So because I applied a template, I picked up this row set from the previous study, and that row set in this case says I'm going to identify all the patients from France. So I've selected a variable country, I've selected the value associated with that country, which is France, and I'm on the subject delete tab. So what this will do is it will delete all of the subjects across all of the tables that have this condition. So a list is created of all the patients that are from France, and across all of the tables, those patients will be deleted. So that's an important way of removing patients across many tables. It might be a patient has specifically said, do not include my information. They can be removed directly in this way. Maybe you can't include the patients from France. Maybe there are other situations where you need to remove patients from the data for a specific reason. So that's row sets as it relates to deleting patients. The other place that row sets might be relevant is we're going to look at some lab data. So the lab data has already had a bunch of rules applied to it again because we brought it in from a template. Here's the date to year rule that carries forward everywhere. If I want to, I can also actually just be specific. I can also change that for an individual column, individual date column. I can do something different. That's fine. So maybe all my dates are subject date offset, and one of them is really date to year. However, I want to manage the process. And this is actually a date time, so we've got a lot of flexibility here. But when I talk about row sets for laboratories, what I want to do here in this case is I created another row set. I'm on the selected rows to de-identify tab. And the name of this row set is where the test name, the lab test name, is HIV viral load. So in this example, imagine HIV viral load has been captured for every patient as part of the due course of the trial. But from a de-identification perspective, we want to still show that information has been captured, but we don't actually want to show the information because that's a sensitive topic and puts that patient at risk. If the information somehow got disclosed, or if there's some indicator of who that patient is, that's not a situation that anybody wants to be in. So what I've done similarly is I've selected the lab test column where the lab test name is HIV viral load. So I've created a subsetting rule, a row set rule. And then when I come back to my lab table, what I can do is I can say where my test is HIV, where the test is named HIV viral load, and this has already been selected here. I want to apply a specific rule to the results information. Maybe I want to cross it out. Maybe I want to just send them to missing. That's fine. The point here is that I've got a way to selectively apply rules based upon selection criteria. So a lot of flexibility, a lot of robustness in how the work can be de-identified. What I'm going to do at this point is actually run de-identification across this entire project. So you can see that if you were quick, you can see that the jobs field opened up. And what I'm going to do is quickly just mark all the tables as complete. I'm going to go on the assumption here for the moment that I've reviewed this information. I'm satisfied with this done. I'm going to sign off and turn it over to the reviewer. I know we're fighting the time a little bit here. So we just work through each one of these. I can actually select them together as well. So while this is churning, I want to try to highlight some of the things that we've learned along the way. So we've learned that the application doesn't require SAS programming. We've learned that there is a lot of flexibility in how these rules are being applied. We've learned that we're not being prescriptive in specifically which rules are relevant. That's something that from a business process perspective, we can talk with you about, or your own internal disclosure group can talk about. But there's a lot of flexibility in how to apply these rules. I've marked these all as complete. So my job as the de-identifier is done. I'm going to log back, not log back, and I'm going to provide my credentials here to confirm that I'm signing off on this. I get a message here that the request to get the data has been submitted. I'm going to log out quickly here, log back in with a different set of credentials as a reviewer. And you can see here I've got this review pending. That's from the project that I've been working on. So I'm going to quickly go through this project. And we haven't really looked at the data yet, so I'm going to just spend some time on the demographics data. And I'm going to view the data. And I've got three views as a reviewer and actually as the person doing the de-identification work. The three views are the original data, the raw data, which we'll start with. So what did I have to work from at the original point in time? And that's going to be a typical grid of columns and rows of information represented as it does in the raw information, whether it's active arm, age, and so forth. I've got the view of what the processed data looks like after it's been de-identified, so I can see what the data will look like after it's been exported out of the system. And here are just examples where you can see the standard deviation rule was applied. You can see the date rule was applied. If we scroll around, you'll see columns that were deleted because they're from France and so forth. So there's a way to see what the data looks like afterwards. Actually, obviously in the export, the deleted patients won't be there, but they're shown in the view, so you can at least see that the work has been done correctly. And what's probably the most useful view is the comparison view of old value versus new value. That's probably the best way to see that the work's been done correctly. So you can see the placebo has been de-identified the same way between these two patients. Age, in this case, it was 59, which is on the lower end of the standard deviation rule. You can see the original date and the year date. And if I scroll through, or if I walk through each column, you can see how the data has been affected based upon the rules that have been applied. As the reviewer, when I'm satisfied and I've clicked through each table and done the review as I see fit, I can come back and I can sign off on it. Actually, I can reject it if I want to. I reject it, give a reason. I've identified this as part of the review process, and here are my concerns. In the interest of time, I'm actually going to just accept it. I'm going to provide my reviewer credentials in this case. That says the sign-up has been accepted. That's great. I'm going to log back out, log in one last time. And you can see that the project I've been working on has been accepted. I can now export the contents out of the system. I couldn't export it before. When I do that, I've got some choices in how that information gets shared. I can pick the format for how the information gets exported, where I want it to go through the browser or to a defined destination, what I want to call it. We do export the content as a zip file. It's just an expedited way of removing that content. And whether or not I want to include the non-tabular files, the reference documents, we do want to make sure folks understand that there's nothing in those files that would be identifying, because we're not touching them as a process to pass them through. When that information is exported, a zip file gets created. Like I said, I'm just doing this locally. And you can see that actually in this case, all of the tables that have been de-identified have been prefixed with characters that say DID. There's some flexibility around how that is provided, or how that's named. The protocol, which was just transferred through, and the report that automatically gets created. And in the wonders of Adobe, that opened on my other screen. Let me just bring that over real quick. So you can see that the project was created as today by a project manager, which is also my set of credentials. Here are the tables. Here's the reference document. And then if we scroll a little further down, we won't spend a lot of time here because we really are short on time. You can see that for all of the columns that had a rule applied, there's a documentation that shows what rule was applied. These columns are scrambled. Here's the age rule with the statistical outlier rule, and so forth. All of that is managed within the system. It shows who signed off on the project as well. So it's a lot of content in a short amount of time. I do apologize for that. Hopefully the demonstration itself has been useful for everybody. One of the things I think it's probably worth talking about at this point is, where are we in terms of next steps, and what's the take-home message here? And I think for a lot of folks, the take-home message is that there is significant growth in the need to de-identify clinical trial. There are a lot of folks asking for this data internally, externally, publications, researchers, other folks that want access to information. So the need is there. The tools, the historic tools that have been in place have been successful to the degree they can be successful, but in a lot of ways they are too time-consuming, too labor-intensive, and ultimately too costly. What Blur provides is the ability to deliver this high-quality, de-identified trial data to whoever it needs to go to at a cost that is more in line with the volume of work that's appearing. And that's an important consideration. We don't want the challenge of doing de-identification to be an obstacle to delivering that. And we've heard that from other customers in terms of once folks start realizing they can get access to the information, they want more information as opposed to less. So the easier we make the ability to deliver de-identified data, the more the volume of that work will grow as well. There is a recognition that there's a lot of valuable information to be shared, and the tools to share that should not be an obstacle to actually making that data available. So with that, I will open the floor to questions. I'm trying to work the window here. Hang on one second. But I have
Dave, I can help you with that.
Okay.
I can help you with that, Dave. So we have a number of questions here. The first one is the focus on standardization, automation, and reducing effort risks trivializing the process, since in the light of privacy, legal, and ethical concerns, the effort and iterations involved in custom processing a study allow a more thorough vetting of the data and handling of specifics that might be missed using more automated means. How would you address this, particularly for legacy trials where the informed consent was more narrow and where more caution might be needed? Quite a mouthful.
So So actually, I kind of read it now. So certainly the goal is not to trivialize the work. You know, we even when you, as I mentioned before, even when you've got like a perfect match between a template and your current project, there's an expectation you need to provide the due diligence to understand how the rules will be applied and whether what additional steps might be necessary within the application or within the application to perform the de-identification work in accordance with your company's business processes and challenges. The related part of that is if we make the work too hard to do in terms of de-identification, and every time a request comes in, it's an onerous task to actually get the de-identification work done, we're really not unlocking the value of that data. So there's certainly the need to balance the value of that information, the desire of patients to share their information, the desire of pharmaceutical companies and other researchers to extract value out of the information that's being collected, but to balance it against the ethical and legal challenges that do exist. We think, you know, from an application perspective, Blur provides that capability, but it's not a substitute for the due diligence that has to be performed. That's why there is the aspect of somebody doing the work, somebody reviewing the work, so it's at least two sets of eyes on the project, and making sure that the rules have been applied, the data has been reviewed, and then it's following the internal business process that is most relevant for the company doing the work. Got another one, Keith?
Thanks, Dave. Yes, I do. Second one here. If the dates are offset, how is it possible to recreate the data analysis? For example, the number of AEs during treatment phase.
So it's a good question, and the goal here is to preserve the utility of the data so you can do things like that example at the same time as protecting the patient's information. If you apply the way the data offset rule works is every patient is assigned every patient is assigned a random number. So patient 1 might be assigned 17, patient 2 might be assigned 150, whatever those numbers are, and all of their dates are shifted by the same amount of time. So if you're trying to calculate, you know, days from one event to another event, or you know, time to event based upon the start date for that patient, all of their dates have been shifted by the same amount. So the relativity of those dates is preserved, but the dates themselves have been changed in such a way that protects somebody from going, oh, I know which patient was at which doctor on which date.
Okay.
Any more?
Thanks, Dave. Yep. We have two more here. We're at 2 minutes left, so just to give you a time check. Throughout the presentation, the term de-identification has been used. We also use the term anonymization in the landscape of clinical trial data transparency. I understand there's a subtle difference related to handling the link between the original and the modified data set. Can you address this in relation to the Blur product? In particular, are the audit and traceability features possibly conflicting with the definition of anonymization?
So this is probably a question that's going to take more than 2 minutes to answer, but I will do my best. So a lot of times the terms are used interchangeably. For folks that are a little closer to the project or a little closer to the process, they understand there's a difference between those terms. In simplistic terms, and like I said, we can have a much longer conversation about this, but in simplistic terms, how a lot of people treat the difference between de-identification and anonymization is that de-identification is the act of transforming the data so that it is different from the original data and doesn't lead back to a patient. Part of that process involves mapping the original user ID, you know, patient ABCD, to a new user ID 12345, and doing that obviously for all the patients. Many times what anonymization refers to is destroying the linkage between the old and the new, so that the map that says ABCDE is 12345 is destroyed as part of the process, usually at the end of the process. By itself, that sounds nice and a clean way of dealing with it, but the question has arisen from actually multiple customers that we've talked to is, whether or not that actually needs to be preserved. Perhaps there's a follow-on study and you want to actually have the same de-identification rule applied, or somewhere down the road, a different data set, a different table gets identified, and this project's already been closed, and it needs to be de-identified the same way, but the key has been destroyed per the anonymization process. So it's a balancing act in terms of what makes the most sense for each company in terms of their long-term plans and their short-term plans. One of the customers we're talking to wants to de-identify data for the same trial every year. It's a long-term trial. They want to do it every year for 5 years. They want to preserve that key mapping so that it can be used consistently from year to year. At the same time, they also want to destroy it. So it's a combination of factors that ultimately factor into the decision. We are being very careful from an audit trail and a documentation perspective that we're following the expectations around de-identification and anonymization. And at least from our perspective, we work with a customer at the onset of a project of a system implementation to understand what they're trying to accomplish and how they want to accomplish that, because the rules the expectations do vary depending on who you speak to, and we recognize that there's a need for flexibility in how this information gets managed, and we've built that flexibility into the system.
Okay, good job, Ted. Thanks. So we're beyond the 12 o'clock endpoint here, and I do have several other questions. I think maybe it's best that we sign off here, and as I promised earlier, we will follow up with a list of the actual questions and answers for everyone that's attended or registered for the event. As Dave mentioned, for more information, you can go to our webpage, dwise.com/blur, or contact Dave at his email listed here or his phone number. Thank you again for attending, and we'll be in touch with you. A recording, like I said, will be coming within 48 hours or so. Okay? Thank you very much. Thanks, Dave, for your fine effort, and we look forward to talking to you.